You feel perfectly still right now. The room around you looks solid. The floor feels completely stationary beneath your feet. But you are not still. You are currently strapped to a giant rock hurtling through the dark vacuum of space at 67,000 miles per hour. That is 107,800 kilometers per hour. Faster than any bullet ever fired. Faster than any rocket humans have ever built. And that is just the beginning. Your entire solar system is spinning around the center of the Milky Way at over 514,000 miles per hour, 828,000 kilometers per hour. And our entire galaxy is hurtling towards something called the Great Attractor at 1.3 million miles per hour. Layer after layer of speed, each more insane than the last. Now think about this. Get in a car. Drive 60 miles per hour with the windows down. The wind rips at your face. Your eyes water. Your hair flies everywhere. But 67,000 miles per hour? Shocked, your coffee sits perfectly flat. Your hair is not blowing. A coin balanced on the dashboard would not move. So why do you feel absolutely nothing? Is your brain tricking you? Is the universe lying to you? Or is something far stranger going on? Something that changes the way you understand motion, stillness, and reality itself. Let me show you. Before we break reality and figure out why nature plays this magnificent trick on your senses, if you enjoy understanding how the universe actually works, not the simplified version, but the real thing, consider subscribing. Because this is not just physics. This is how the world actually works. To understand why you cannot feel this insane speed, we have to go backward in time. Back to when humanity first figured out what motion even is. For thousands of years, common sense ruled. Push a cart. It moves. Stop pushing. It stops. Things want to stop. Moving is a special condition that needs a pusher. Aristotle himself said it. Objects have a natural place. Rocks fall because they belong on the ground. Fire rises because it belongs in the sky. Push something, it moves. Stop pushing, it rests. For 2,000 years, nobody questioned this, because it seems so obvious. But nature is absurd. Common sense is almost always wrong when it comes to the deep rules of the universe. Along comes Galileo, around 1600, and he starts doing something nobody else thought to do. He starts playing with smooth balls rolling down inclined planes. Simple experiments, almost trivially simple. But watch what happens. Roll a ball down a ramp, it speeds up. Of course it does. Gravity is pulling it down. Now roll it up a ramp, it slows down. Again, obvious, gravity is working against it. But here is where Galileo had his genius moment. What if the surface is perfectly flat, perfectly smooth? No friction at all? The ball does not speed up. It does not slow down. It just keeps going in the same direction, at the same speed, forever. It does not need a pusher. It does not need to remember that it is moving. It just moves. Think about what Galileo just destroyed. 2,000 years of things naturally stop. 2,000 years of Aristotle. Gone. Because a ball on a smooth ramp said otherwise. Being in motion is just as natural as standing still. That is the first reframe. And it changes everything. But here is where it gets interesting. Why does a thing keep moving? Is there some magic juice inside it? Some invisible engine that propels it forward? No, it just does. We do not know why the universe follows this rule. We just call it inertia, which is just a fancy word for We do not know why it keeps going, but it does. And that honesty, that admission, that is physics at its finest. We do not make up stories. We describe what happens. And what happens is this. Objects in motion stay in motion unless something acts on them. Period. Galileo discovered that motion is natural, but he also discovered something even more profound, something that directly explains why you cannot feel 67,000 miles per hour, 107,800 kilometers per hour. Galileo asked you to imagine something. You are locked inside the belly of a large sailing ship. No windows, no portholes, just a sealed room below deck. And the water outside is perfectly calm. Inside this room, you have a bowl of fish swimming in water, butterflies flying around, a faucet dripping water into a bucket below. The ship is sitting at dock, not moving. You watch everything carefully. The fish swim equally in all directions. They don't prefer one side of the bowl over another. The butterflies flutter wherever they want. No pattern, no preference. The water drips straight down from the faucet into the bucket. Perfectly vertical. Now throw an apple to your friend across the room. It arcs through the air and lands in their hands. Easy. Normal. Jump straight up. You land in the same spot. Pour a glass of wine. It pours in a clean stream, straight down. Everything behaves exactly the way you expect. Now here is the critical moment. The ship starts moving. 20 miles per hour, about 32 kilometers per hour. Smooth, constant speed. No acceleration, no turning. Just straight ahead on perfectly calm water. What changes inside your sealed room? Nothing. Absolutely nothing. The fish swim the same way. No preference for any direction. The butterflies flutter identically. The water drips straight down into the bucket. Not an inch off. Throw the apple, same arc, same catch, jump up. Land in the same spot. Pour the wine, same clean stream. Every single experiment you can perform inside that sealed room gives you the exact same result. Whether the ship is sitting still at dock or cruising at 20 miles per hour, 32 kilometers per hour. Now push it further. What about 50 miles per hour? 80 kilometers per hour? Same. 200 miles per hour? 320 kilometers per hour? Same. 67,000 miles per hour? 107,800 kilometers per hour? Same. As long as the motion is smooth and constant, no speeding up, no slowing down, no turning, everything inside that room is identical. Inside that room. You cannot do a single physical experiment to prove whether you are moving or standing still. Read that again. No physical experiment. Not a clever one. Not $1 billion one. Not one that hasn't been invented yet. None. The laws of physics are exactly the same whether you are moving at constant speed or not moving at all. This is the principle of relativity. Galileo's second revolution. And here is the reframe that changes everything. Space is not a stage with invisible coordinate lines painted on it. There is no giant grid in the sky telling you, you are here moving at this speed. Motion is only relative. You can only say you are moving relative to something else. Relative to the dock. Relative to the shore. Relative to the sun. But there is no absolute motion. No cosmic speedometer, no universal still. And that is why you cannot feel 67,000 miles per hour. So say because 67,000 miles per hour only means something relative to the sun. Inside your sealed room, on your sealed planet, there is no experiment that can detect it. You are Galileo's ship. Earth is the sealed room. The sun's gravity provides the calm water, and you are sailing through space with butterflies that flutter normally and wine that pours straight down. Now that is a beautiful answer. But I need to be honest about something. Because everything I just told you is not entirely true. And the reason it is not entirely true matters deeply. Galileo's principle says you cannot detect motion from inside a sealed room. And for uniform motion, constant speed, straight line, that is absolutely correct. But Earth is not moving in a straight line. Earth is spinning. Once every 24 hours. And anything that spins is not moving in a straight line. It is changing direction constantly. And in 1851, a French physicist named Léon Foucault proved it. He hung a massive pendulum from the ceiling of the Pantheon in Paris. 67 meters, about 220 feet, of wire with a 28-kilogram, 62-pound brass ball at the bottom. He set it swinging, back and forth, in a straight line. And then something extraordinary happened. Over the course of hours, the plane of the pendulum's swing slowly rotated, without anyone touching it, without any force applied sideways. The pendulum wasn't turning, the floor was. The entire building was rotating underneath the pendulum as Earth spun. From inside a sealed room, you can detect rotation. You can detect that Earth is spinning. This is the Coriolis effect, the same force that makes hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern. The same force that military snipers must correct for when shooting over long distances. A bullet fired straight can drift sideways because Earth rotates underneath it during flight. So here's the honest correction. The third reframe. Not all motion is undetectable. Only uniform motion, constant speed in a straight line. Spinning is detectable. Acceleration is detectable. Turning is detectable. But cruising through space at 67,000 miles per hour, 107,800 kilometers per hour, in a smooth, nearly straight orbit? Completely invisible. Completely undetectable. Completely unfelt. Galileo was right. With one small asterisk. And that asterisk, that tiny distinction between uniform and non-uniform motion, would become the foundation of everything Einstein built next. So Galileo figured out that uniform motion is natural and undetectable. But one man took this idea and ran with it further than anyone thought possible. Isaac Newton. Newton looked up at the night sky and saw the moon, and he asked a question that nobody had properly answered. Why does the moon not fly off into space? Why does it stay circling Earth? And then he had the insight. The moon is flying off into space. It is moving in a straight line, trying to obey Galileo's inertia. But something keeps pulling it back. Something keeps bending its straight path into a curve. Gravity. The same force that pulls an apple from a tree reaches out across 240,000 miles, 384,000 kilometers, and holds the moon in orbit. The moon is not floating. It is falling continuously around the Earth, missing the ground every single second. Newton wrote down the mathematics, and those equations worked with terrifying precision. You could predict where Jupiter would be 10 years from now. You could predict eclipses down to the minute. You could calculate the tides, the trajectories, the orbits of comets that would not return for centuries. It was a triumph of human thought. One set of rules that described everything that moves, from a falling apple to a spinning galaxy. But there was a crack, a tiny, uncomfortable flaw that Newton himself could not fix. How does the Earth reach out across 240,000 miles of completely empty space and pull the moon? Is there an invisible rubber band? Some kind of cosmic rope? How does a magnet push another magnet away without touching it? It is easy to say gravity pulls the apple. But how does the apple know the earth is there? There is nothing between them, just vacuum, just emptiness. Newton's math told you what happens. It told you exactly how fast the apple falls and exactly how the moon orbits. But it never told you why. And that unanswered question, that crack in the most successful theory in human history, brings us directly to the real secret of why you cannot feel speed. Because here is the fourth reframe. And this one changes everything. Speed is an illusion. There is no such thing as absolute speed in the universe. It is a completely meaningless concept. Let me explain. Because this is deeply counterintuitive, and it starts with the simplest question. Why do you feel the car but not the earth? Your body is a machine, a messy, beautiful collection of atoms jiggling around, arranged in cells and nerves and organs. And this machine has sensors. It detects pressure. It detects temperature. It detects acceleration. But it does not detect speed. Your body is not a speedometer. Your body is an accelerometer. That is the fifth reframe, and it is the core answer to the entire video. You are equipped to feel the pushes, the pulls, the sudden jolts, the changes, but you are completely blind to steady motion. Let me show you exactly what I mean. Get in a car. Put your foot on the gas. What happens? You are pressed back into the seat. Your speed is changing. The seat has to push against your back to accelerate your mass, to force your body to keep up with the car. You feel that push. Now slam on the brakes. The seatbelt digs into your chest. Your body wants to keep moving forward. Inertia, remember. But the belt forces you to decelerate. Your speed is changing again. You feel that too. But now you are cruising on the highway. 60 miles per hour, 97 kilometers per hour. Perfectly steady. Windows rolled up. What do you feel? Nothing. Absolutely nothing. You could balance a coin on the dashboard. You could pour coffee without spilling a drop. Close your eyes, and you would not know you are moving at all. The only reason you know you are moving is because you see the trees whipping past through the window, and the car vibrates slightly because the road has bumps. Take away the visual cues and the road imperfections, and you feel perfectly still. Now think about a bullet train in Japan, the Shinkansen, traveling at 200 miles per hour, 320 kilometers per hour. Inside, you can balance a pen on the tray table. Passengers sleep peacefully. A child can stack blocks on the floor. 200 miles per hour, and it feels like sitting in your living room. Now think about an airplane, cruising at 35,000 feet, 575 miles per hour, 925 kilometers per hour. Close your eyes during smooth flight. Your body registers zero motion. Absolutely none. Now think about Earth. The Earth is the ultimate luxury vehicle. It is coasting through the vacuum of space at 67,000 miles per hour, 107,800 kilometers per hour. There are no potholes. There is no air resistance. There are no road imperfections in the vacuum of space. No turbulence. No vibration. Nothing. It has been moving at this steady, smooth pace for over 4 billion years. 4 billion years of perfectly constant motion. And your biological accelerometer, the same machine that detects every bump in the road, every brake tap, every elevator jolt, registers absolutely zero change. Because there is no change. The Earth is not speeding up. It is not slowing down. It is not jerking sideways. It is gliding through empty space with a smoothness that no human vehicle can match. And here is the mind flip. Your baseline for stillness, the feeling of sitting perfectly still in your chair right now, is actually astronomical speed. Your zero is 67,000 miles per hour. Your body cannot tell the difference because there is no difference. Steady motion and perfect rest are physically, measurably, absolutely identical. So you only feel change. And your body is an accelerometer, not a speedometer. But what if there was a change? What if something actually disrupted that perfect steadiness? What if Earth suddenly stopped? Not slowed down over millions of years, not gradually drifted to a halt. Stopped. Dead. In 1 second. Here is what would happen to you. Your chair would stop. The floor beneath you would stop. The building around you would stop. But you would not stop. Your body would keep moving forward at 67,000 miles per hour. That is 107,800 kilometers per hour. That is 30 kilometers per second. You would be launched sideways through the wall of your house like a bullet through wet paper. Not thrown, launched, at a speed that makes a rifle bullet look slow. And it would not just be you. Every building on the surface of the earth would be ripped from its foundation and flung eastward at 67,000 miles per hour. Every mountain, every bridge, every tree, every ocean. The oceans would keep moving. Try massive walls of water, tsunamis thousands of feet high, would wash across entire continents like a bathtub tipped sideways. The atmosphere, all of it, would keep going too. Winds of 67,000 miles per hour, over 90 times the speed of the strongest hurricane ever recorded, would scour the surface clean. Down to bedrock. Everything not bolted to the core of the planet would become a projectile traveling faster than any weapon ever built by human hands. The entire surface of our planet, sterilized, in seconds. Think about that for a second. This is the speed you are actually moving right now. This is not hypothetical speed. This is not abstract physics. This is the real, measurable, violent speed of your body through space at this exact moment. You just do not feel it. Because nothing is changing. The violence is hidden inside the steadiness. And that is the deepest proof that your body is an accelerometer, not a speedometer. The only reason you are safe, the only reason your coffee sits flat and your hair stays still and your world feels solid, is because the speed is perfectly constant. The moment it changes, even for 1 second, the invisible becomes catastrophic. So speed itself is harmless. Change is what kills. Acceleration is what you feel. And right now, your acceleration is 0. So your sensation of speed is 0. Even though the speed itself is enough to destroy every civilization that has ever existed. But wait, it gets weirder. Let us dive deeper into what is actually happening when you feel a push, when you feel the seat pressing against your back, when you feel the floor holding you up. Because here is the thing, you are not actually touching anything. When you sit in your chair, you think you are touching the chair. You feel the pressure on your legs and your back. You think the solid matter of your body is resting on the solid matter of the chair. But nothing is solid. If you could zoom in, way in, past the fabric of the chair, past the molecules, down to the individual atoms, what would you see? Mostly nothing. Empty space. An atom is almost entirely empty. A tiny, incredibly dense nucleus in the center, protons and neutrons packed tight. surrounded by a vast cloud of buzzing electrons. If the nucleus of an atom were the size of a marble sitting on the 50-yard line of a football field, the nearest electron would be somewhere in the parking lot. Everything in between? Empty. And you are made of these atoms. Your chair is made of these atoms. The floor beneath you, the walls around you, your own bones and skin and blood, all mostly empty space. So when you sit down, what is actually happening? The electrons on the outer edge of your atoms are getting close to the electrons on the outer edge of the chair's atoms, and electrons have a negative electric charge. You know what happens when you bring two negative charges together? They hate each other. They repel, fiercely, with a force that is 10 to the 36th power, that is a 1 followed by 36 zeros, times stronger than gravity. The electromagnetic force between those electron clouds is so powerful that they never actually touch. Not ever. Not even close. You have never touched anything in your entire life. Every handshake, every kiss, every time you held someone's hand, you were floating, a tiny, immeasurably small fraction of a nanometer apart, suspended on an invisible cushion of electromagnetic repulsion. That repulsion is what you feel. When you sit in your chair, the electrons in your body push against the electrons in the chair. That electromagnetic push is the solid feeling. That is what your nerves detect. That electromagnetic force is the sensation of touch. Now connect this back to speed. When a car accelerates, the seat pushes against your back. What is really happening? The electrons in the seat fabric are pushing harder against the electrons in your shirt. More electromagnetic force, more squeeze. Your nerves detect the change in electromagnetic pressure. You feel the push. But when the Earth is moving at a constant 67,000 miles per hour, 107,800 kilometers per hour, there is no extra push. There is no extra squeeze. The electromagnetic force between your atoms and your chair's atoms is exactly the same, whether you are sitting still at a traffic light or hurtling through space. Everything is moving together, perfectly synchronized. Your atoms, the chair's atoms, the building's atoms, the atmosphere's atoms, the entire planet's atoms, all traveling at exactly the same speed in exactly the same direction. No relative motion between your body and your environment means no change in electromagnetic force. No change in electromagnetic force means no change in the signals your nerves send to your brain. No change in signals means no sensation. So speed is just an illusion. You only feel a jolt. You only feel the change. And right now, sitting perfectly still in your chair, you are floating on electromagnetic fields. I'm traveling at 67,000 miles per hour through a universe that does not care how fast you are going. But if speed is meaningless at the atomic level, if your atoms cannot tell the difference between rest and 67,000 miles per hour, then what happens when we zoom out to the entire universe? What is speed? What is time? What is space? Because Einstein had an answer, and it is stranger than anything we have discussed so far. Einstein came along and asked the most dangerous question in physics. If the laws of physics are the same for everyone, if no experiment can tell you whether you are moving or standing still, and the speed of light is always the same for every observer, no matter how fast they are moving, then something else has to give. Space and time cannot be fixed. Let me show you what this means, because it is going to sound insane, but it is real, and it has been measured. Imagine you have a long sausage. You take a knife and slice it straight across, perpendicular to the length. You get a perfect circle, Clean, round, symmetrical. Now tilt your knife at a slight angle and slice again. Same sausage, same meat, but the slice is an oval, longer, stretched. Tilt the knife even more. The oval gets longer and thinner. You are cutting through the exact same sausage, but because your angle changed, the shape of the slice changed. Space and time are that sausage. The universe is not 3 dimensions of space with time ticking separately like a clock on the wall. It is a 4-dimensional block. Spacetime. One unified thing. And every moment of your life, you are slicing through this block. When you and I are sitting still relative to each other, we are slicing the space-time sausage at the same angle. We agree on what right now means. We agree on distances. We agree on how fast time passes. But if you get in a spaceship and fly past me at half the speed of light, you are now slicing space-time at a different angle. Your slice of right now cuts through my future and my past. What you call simultaneous events. 2 things happening at the exact same moment. I call events happening one after another. Your clock ticks slower from my perspective. Your spaceship looks physically shorter from my perspective. And this is not an optical illusion. It is not a trick of perception. The actual geometry of the space and time you occupy has changed relative to me. The faster you move relative to me, the more your slice tilts, the more time stretches, the more space compresses, and there is a limit. The speed of light, 299,792,458 meters per second, about 671 million miles per hour. But here is the thing most people get wrong. The speed of light is not really about light. It is the speed of causality, the maximum speed at which one event can cause another event, the maximum speed of information transfer in the universe. If you could travel faster than light, you would tilt the sausage slice so steeply that the effect would happen before the cause. You could receive a reply to a message before you sent it. You could see someone catch a ball before you threw it. Nature forbids this. Absolutely. Without exception. And this is why you cannot just teleport to the other side of the universe. Traveling requires time because motion is fundamentally tied to the structure of cause and effect itself. Now, here is where most videos about relativity stop. They give you the sausage. They give you the mind-bending thought experiment, and then they move on. But I want to show you something. Because Einstein's space-time is not just beautiful philosophy, it is engineering reality, and it is running in your pocket right now. GPS satellites orbit Earth at about 14,000 kilometers per hour, roughly 8,700 miles per hour. That is fast, but not even close to the speed of light. Yet Einstein's equations still matter. Because those satellites are moving relative to you, their clocks tick at a slightly different rate than your clock on the ground. The difference? About 38 microseconds per day. 38 millionths of a second. That sounds tiny. Irrelevant. Who cares about 38 microseconds? Your GPS does. Because light travels about 11.4 kilometers in 38 microseconds. If engineers ignored Einstein, if they pretended space-time was flat and clocks all tick the same, your GPS position would drift by about 10 kilometers every single day. By the end of a week, Google Maps would put you in a different city. Every single time you open Google Maps. Every time an airplane lands safely using instrument guidance. Every time a delivery truck finds your house. Count every time an ambulance navigates to an emergency. Einstein's equations are running in the background, correcting for the fact that time flows differently for satellites than for you. And in 1971, 2 physicists, Joseph Haefel and Richard Keating, decided to test Einstein directly. They put ultra-precise atomic clocks on commercial airplanes and flew them around the world, eastbound and westbound. When the planes landed, they compared the airborne clocks to identical clocks that stayed on the ground. The clocks disagreed by exactly the amount Einstein's equations predicted, down to the nanosecond. The sausage is real. We have measured the different slices. Time genuinely flows at different rates, depending on how fast you are moving. And this answers the crack in Newton's theory. Remember the question, how does gravity reach across empty space? Einstein's answer, it does not. Mass does not pull objects through space. Mass bends spacetime itself. Objects follow the curves. The Earth is not pulling you down. The Earth's mass has curved spacetime around it, and you are following that curve. Newton told you what happens. Einstein told you why. And the why turns out to be the geometry of the universe itself. So we are hurtling through space, slicing through time, completely unaware of the astronomical ballet we are part of. Let me put this all together. This is because the full picture is terrifying and beautiful. You are a collection of atoms, roughly 7 octillion of them. That is a 7 followed by 27 zeros. Each atom is mostly empty space. Those atoms are held in shape not by anything solid, but by electromagnetic fields, invisible forces pushing and pulling and vibrating. Those atoms are arranged into cells. Those cells form organs. Those organs form a body that breathes and thinks and wonders about the universe. And that body, your body, is currently falling. Not falling toward something, falling along something, falling along the curved geometry of spacetime created by the mass of the sun. The Earth is not orbiting the sun the way you think, like a ball on a string being swung in a circle. The Earth is falling freely through curved spacetime, and you are falling with it. You are in permanent free fall right now. You have been in free fall your entire life, and if you zoom out even further, our sun is falling along the curved spacetime of the Milky Way at 514,000 miles per hour, 828,000 kilometers per hour. And our galaxy is falling toward the Great Attractor at 1.3 million miles per hour, 2.1 million kilometers per hour. Layer after layer of freefall, each one invisible, each one unfelt. If you really think about it, this can give you a bit of existential dread. You are sitting there feeling completely stable, completely solid, completely still. But in reality, well, you are a ghost of probability waves and vibrating electromagnetic fields. You have never touched anything. You are floating on invisible forces. You are locked in a permanent free fall through a universe that does not have a center, does not have an edge, and does not have a fixed background. There is nowhere in the universe that is truly still. No cosmic ground floor. No absolute reference frame. Just relative motion, all the way down. And your senses, the biological instruments that evolution spent billions of years building, cannot detect any of it. Because those instruments were built to detect change, acceleration, jolts, threats, not the silent, perfect, ancient velocity of a planet gliding through empty space. But I think it is beautiful. Because here is what it means. You are not separate from the universe. You are not an outside observer looking in through a window. You are part of it. Your body, your brain, your very senses. They are constructed from the exact same rules that govern the stars. The same electromagnetic force that holds your atoms together lights up the sun. The same space-time geometry that bends light around black holes is the reason your GPS works. The same inertia that keeps a ball rolling on Galileo's ramp keeps you gliding at 67,000 miles per hour without feeling a thing. You are not being tricked. The universe is not lying to you. It is operating with such a profound, elegant symmetry that steady motion and perfect stillness are exactly the same thing. Think about what we have discovered together in this video. Galileo showed us that motion is natural. A ball on a smooth surface rolls forever. No pusher needed. His ship showed us that uniform motion is undetectable. Butterflies fly the same, wine pours the same. No experiment can tell you if you are moving or still. Foucault's pendulum showed us the honest exception. Rotation is detectable, because rotation is acceleration. Galileo's principle holds, precisely. Newton gave us the mathematics of everything and revealed the crack that demanded a deeper truth. Your body gave us the core answer. You are an accelerometer, not a speedometer. You feel changes. You are blind to constancy. The Earth stopping showed us the violence hidden inside the steadiness. 67,000 miles per hour of destruction, masked by perfect smoothness. Your atoms showed us that touch is an electromagnetic illusion. You have never made contact with anything in your entire life. And Einstein showed us that space and time are not the stage. They are part of the performance. They bend. They stretch. They flow at different rates depending on how fast you are moving. And we have measured it. With atomic clocks, with GPS satellites, with the phone in your pocket. We cannot feel the 67,000 miles per hour because we are perfectly in tune with it. Every atom in your body, every atom in your chair, every atom in the air you breathe, all of it traveling at exactly the same speed, all of it embedded in the same slice of space-time. We are lucky. We are lucky to be here. We are lucky to have enough brains to figure out how absurd and wonderful nature truly is. We do not know why the universe works this way. We do not know why inertia exists. We do not know why the speed of light is the speed of causality. We do not know why mass bends space-time. It just does. And discovering that, peeling back layer after layer of reality to find deeper and deeper truths, that is the greatest adventure of all. Next time you are in a car, cruising at highway speed, close your eyes for a moment. Feel that perfect stillness, that silence, that zero sensation. That is the same physics that hides 67,000 miles per hour right now. The violence is always there, hidden inside the steadiness. And the fact that you cannot feel it is one of the most profound truths about the universe you will ever encounter. If this changed the way you see the world, share it with someone who needs a little perspective shift today. Remember, you are never truly standing still, and that is beautiful.